Hello everybody, Harry from GMAT Ninja here, and welcome back to our series of quant videos for the GRE. Today's video we're going to be taking a closer look at arithmetic and algebra, and to start with I'm going to take us right back to the beginning. We're going to go take a look at the real basics. What do you absolutely need to know in order to be able to answer a quant question on the GRE? We'll do a few warm-up questions in order to get through those foundational topics, and then I'm going to increase the difficulty level as we work through the video. As we do that, we'll take a look at the different ways the GRE can twist and turn a question. And so really what I'm focusing on there is what to look out for. What should you focus on in a question? Finally, the last thing we're going to really focus on today, and this will be a theme throughout the series, is don't beat yourself. If you've watched any of our videos, then you'll know that a big part of what we do is to look at exactly how you should approach the question. If you're missing questions that you could, possibly should, answer correctly, those are the ones that are really going to drag your score down. We don't necessarily need you to be able to answer the monstrously difficult stuff. A big part of what we do with the GRE is don't beat yourself. All right, so since I've said that we're going to go right back to the basics, there's going to be some easy questions in today's video. There's certainly the first three, the warm-up questions we're going to start with. Those are for the people that may be just starting out studying for the GRE, or maybe you haven't looked at any maths since school. That might be a few years ago, so you're a bit rusty. Certainly, if you're looking for something over a 160, those first three questions are going to be very easy, and you might want to skip your way through them. Once we've dealt with those three, things are going to start to get a little bit more difficult. So if you're just aiming to scrape yourself a 150, just stick with us as long as you can, but you certainly don't need to be able to answer the final couple of questions. Hopefully those last two, there'll be something to challenge you, even if you're looking for something over a 160. All right, so as I've said, the first three questions are going to be some quick warm-up ones. I'm going to give you about a minute to take a look at this one, then we'll come back, take a look at it together. So I'll get the first question up on the screen for you now, and I'll see you back here in about a minute's time. Okay, if you want a little more time to have a think about this one, now's your chance to pause the video. We'll still be here working the problem through once you get back to us. So I'm going to take the question away so that we can take a look at it together. All right, so hopefully a nice, easy one to begin with. We've just got a quadratic, and we've been asked to find some roots. Before we go into the solution of this problem, I do want to focus on that word roots, because it's not something that everybody's familiar with. It's not something that's a very common way of looking at it. The roots of a quadratic equation are exactly the same as the solutions for the equation in terms of what the GRE is asking you to do. What we're aiming to do with that quadratic, x squared plus x minus 12 equals 0, is I'm going to factorize it into a set of parentheses, and then I'm going to eventually get to an answer, x equals something and x equals something, and each of those are going to be the roots of the equation. Now, as I said, the roots might be the same as the solution, or you might characterize them as the same as the solution. But one more thing, the roots of the quadratic equation are also the points where the graph of this equation will cut the x-axis. Now, for the GRE, you don't need to be able to draw a quadratic equation. They're not going to ask you to sketch it, but they might ask you where the graph of that equation cuts the x-axis, and that's exactly the same thing as the roots. It's exactly the same thing as the solution. We're going through the same process, and so that was just to give you an idea of what these words mean. All right, so as we said, we're looking for the roots of this equation, and that is very similar to just solving it. I've got the structure that I want here set up, so let's go factorize this and put it into a set of parentheses. I've got an x squared at the start of this equation, so the first term in both these sets of brackets is going to be an x there. Because the sign in front of the number at the end of this is a negative one, I know the signs within the brackets are different. If that was a positive 12, then the signs would be the same, either plus plus or minus minus. Now, because I've got a positive x there, plus 1, what I can say is the numbers that I'm going to find here are going to multiply together to make negative 12 and add together to make positive 1. So I know the positive number is going to be 1 bigger than the negative number. Two numbers multiply together to make 12, sum together to make plus 1. It's going to be plus 4 and negative 3. All right, now, most people can very quickly jump from this stage to the final bit, but just so that we know what's going on, just so that we can see what's going on in the background, what I have here is effectively two terms, two things multiplied together, and those two things multiplied together will give me 0. Now, in that case, either one or both of them must be 0. So what I can say is that in order to get this 0, I could say x plus 4 is equal to 0. And so that would give me x equals negative 4. So that would be one of the roots. On the second set of parentheses, I could say x minus 3 is equal to 0. And that would give me x equals 3. So x equals 3 would be my second root. So I've got my two roots there. Now, I know the question said that these roots are a and b, and I don't know which one's which, but for the purposes of this question, it doesn't really matter. What I've got for quantity a here is I've got the sum of these roots, and for quantity b, I've got the product of these roots. So for quantity a, I could add them, and it doesn't matter what order you do them. Negative 4 plus 3 or 3 take away 4 would both give you negative 1. And over here, I'd have negative 4 multiplied by 3, and so that's going to give me negative 12. And so in this quantitative comparison question, what I'm looking for is which one of quantity A and quantity B is greater. In this case, negative 1 is greater than negative 12. So quantity A is the bigger one, and the answer to this question would have been A. All right, nice quick factoring a quadratic question to get started with. We've got two more of these warm-up questions just to look at the foundational topics here. So I'll get the next question up on the screen. You've got about a minute to take a look at this one, and I'll see you back here to take a look at it together. Okay, pause here if you want some more time to have a think about this one. I'm going to take the question away so that we can look at it together. All right, so as I said up at the start of the video, one of the big things we're looking at here is don't beat yourself. And this is the first opportunity where you could have done that. There are times when you'll get something like this, where the quantity A and quantity B in a quantitative comparison question, they look similar. So here I've got a 1 and a 3, and I've got a 1 and a 3, and I've got a plus sign, and I've got a plus sign. It's like, well, they look the same. And if you're in a rush and you're trying to get through this question quickly, maybe you've not managed your time as well as you could, you might leap at this and just go, well, they're the same. Give the answer a C and move on. But that might not be the case. So let's take a closer look and see what's going on here. So I'm going to deal with quantity A first. In this case, I've got the one line separating the top and the bottom of the fraction, one great big line in between. So I could think of this as having parentheses around these numbers. And so I can deal with what's inside the parentheses first. Top line would be 1 plus 2 plus 3 would give me 6. And bottom line 3 plus 4 plus 5 would give me 12. And so overall, quantity A is going to give me a half. All right, so one of the other things we want to take a look at here is where can I save time by being as efficient as possible? And I'm going to take a look at quantity B here. I've got a third. I can simplify 2 over 4 to be a half, and then I've got 3/5 there. Now, quantitative comparison questions, I'm looking at which is bigger, quantity A or quantity B. I know quantity A is a half, but I know quantity B has a half in it, and then I'm going to add on some other stuff. And so I can stop here. I don't need to do any more work. It's going to be a half plus some other things. So it's definitely going to be bigger than quantity A, which is just a half. And that's what I mean when I'm saying, like, let's look for efficiency. Let's look for points where you don't have to go that extra mile to finish this problem off. I could do a half plus a third plus 3/5 and come to an answer and guarantee it was bigger than a half. But at this stage, I'm already certain that quantity B is going to be the bigger one of the two. And so the answer to this question is going to be B. And so we've got to tread that fine balance between, I don't want to rush, I don't want to jump to conclusions. And as I said right at the start of this problem, they look the same, so it's just going to be C. But equally, I don't want to drag this question out far beyond what I need to do. And at the end there, I know a half plus some other stuff is going to be bigger than a half, so I know the answer is going to be B. So we're treading that line between not slipping up and making unnecessary mistakes and not doing too much work and wasting time. All right, I've got one more of these warm-up questions for you, so I'll get this up on the screen. We'll give you a minute to take a look at it, and I'll see you back here very soon. Okay, pause here if you want some more time to take a look at this one. But for now, I'm going to take this question away so that we can work it through together. All right, so I'm actually going to take a bit of a detour at the start of this question because 2 equations and 3 unknowns, that's not the nicest place to start here. I'm actually going to take a look over here at these 2 equations I've got written in red. 2 equations, 2 unknowns. Hopefully we're going to be able to solve these, and we can take a look at how I would go about dealing with simultaneous equations when you're on the GRE. All right, so the first thing I'd be looking for when I get a set of simultaneous equations like this is, are there any similarities between the top line and the bottom line? And by similarities, I mean, if I look at the x terms here, that top line is just double that bottom line. So I've got something I can deal with fairly simply. So in order to do that, I'll just rewrite that top line so that I can work with it together with the bottom line. And now the bottom line, as I said, this top line is double the bottom line. So you might think that I'm just going to go and double the bottom line and subtract the 2 equations. But I'm going to take that second line and multiply it by -2. And so the reason for doing that is so that I can add these 2 lines together. And when I do that, 4x plus -4x will leave me with 0. The x terms will disappear. I've got 13y, and that equals 39. And that gives me an equation I can very simply go and solve for the y term. Now, the reason that I want to add these 2 lines together is so that I can consistently do the same thing throughout the test. Simultaneous equations, it doesn't really matter whether I add or subtract the lines. Simultaneous inequalities, it does. I can only add them, I can't subtract them. And what we find is that when the pressure's on, when, let's say it's section 2 of the quant section, it's question 19, you're beginning to run out of time, you've got some simultaneous inequalities, the time pressure does funny things to your head and you're like, I don't know whether I can add or subtract these. Is that inequalities? Is that equations? And so what we tell our students is, I always, always, always want you to add both simultaneous equations and simultaneous inequalities. So yes, I've added an extra layer of difficulty in here, an extra little layer of difficulty by multiplying that second equation by -2 rather than just 2. But that gives me the consistency that means I'm far less likely to make a mistake elsewhere in the exam, particularly when I've got inequalities involved, simultaneous inequalities involved. All right, so with these equations, we should hopefully be able to finish this off from here. Divide both sides by 13. That'll give me y equals 3. And I can substitute that y equals 3 back into that top line. So I would have 4x plus 7 times 3 is equal to 29. So 4x is 21. Sorry, 4x plus 21 equals 29. 4x equals 8. And that would give me x equals 2. There's my 2 solutions. That's how I would go about dealing with simultaneous equations. It might seem like that extra step, but trust me, when you deal with simultaneous inequalities, that extra step and then adding the two together will prevent the mistakes, that will prevent slip-ups that can help your score. All right, so putting that to one side, let's actually deal with the question we were asked. And go back to the last question we looked at. That was the first time we saw this don't beat yourself idea. This is another opportunity for that. I've got two equations. I've got three unknowns. Now, typically, that means you're not going to be able to solve the set of equations. But if I just leap to that conclusion, I might miss something. So let me rewrite these equations and at least line up the variables. So top one, 7x plus 5y plus 3z is going to equal 6. And then the bottom line, I've got 21x. And I'm going to take the y and the z over to the left-hand side. So I'd have plus 20y plus 9z is equal to 28. Now, what I hope you're spotting here is, well, the x terms, the bottom line is just 3 times the top line. And the z terms, the bottom line is just 3 times the top line. So let me take that top line, and I'm going to multiply the top line by -3. And so I've got negative 21x minus 15y minus 9z is equal to minus 18. I'll rewrite the bottom line, 21x plus 20y plus 9z is equal to 28. And now I can add these two lines together. The x terms will disappear because negative 21x plus 21x will just leave me with 0. Negative 15y plus 20y will leave me with 5y. The z terms will disappear in the same way the x terms did. And negative 18 plus 28 will leave me with 10. Divide both sides by 5, and I will get y is equal to 2. So quantitative comparison question, y is equal to 2, or quantity b is 1. Which is greater, 2 or 1? The y equals 2. That side's going to be larger, greater. So the answer to this question is going to be A. All right, so that's how I would go about dealing with simultaneous equations, both when there's two equations and two unknowns, or even two equations and three unknowns. And as I said, please don't leap to the conclusion that two equations, three unknowns, I definitely can't solve it, because as you can see here, the way the numbers worked out, we got to an answer. All right, so those are the three warm-up questions I said we'd begin with. Now, just a quick caveat before we moved on. If those three questions have completely blown you out of the water and you're looking here going, I'm not really sure what you're talking about, that's probably a sign that this video series is probably going to be a little bit advanced for you. What I would do here is pause the video, go away and find yourself a sort of a basic algebra course, particularly focused on solving equations, simultaneous equations, factoring quadratics, those sorts of things. These are the real foundational topics that you're going to need all over the GRE Quant series. Then, once you're comfortable with that, come back and join us. And as you see now, we're going to begin to increase the difficulty level and take a look at the other ways the GRE can twist and turn a question. All right, so difficulty level of the questions is going to increase slightly as we move forward through the rest of the video. I'm going to get the next question up on the screen. This time, I'm going to give you 2 minutes to take a look at this one. I'll see you back here to work it through very soon. Okay, pause here if you want some more time to work on this one, but I'm going to take the question away so that we can look at it together. All right, as I'm sure you're aware, or at least as I hope you're aware, the GRE gives you a calculator in the exam. So when we're dealing with arithmetic problems like this, the challenge is not going to be multiplying the x and y together once we find them. The challenge in the question like this is going to be figuring out what x and y should be. It's interpreting the question. It's dealing with the problem itself. Right, so what we're told in this question, right, x and y are two-digit integers, and we know that x is going to be less than 30 and y is going to be greater than 65. Now they've got to be two digits, and I want to find maximum value of xy, so I should go about making x and y as big as possible. So the biggest value that x could be, it's a two-digit integer and it's less than 30. Well, the biggest thing that x could possibly be there is 29. Now y is greater than 65, but it is also a two-digit integer. And so the biggest thing that y could possibly be is 99. Can't get to 100, must be bigger than 65. So the biggest thing it can be is 99. And so really all we're asked to do in this problem is to say, well, x times y, that's 29 times 99, and we need to get to a number there. Now, you'd be totally justified in just getting the calculator out, tapping the numbers in, and coming to an answer there. But again, with the students we deal with, there is many opportunities where, or many instances, we're getting to this stage and just typing the numbers into the calculator where people actually slip up here. So it's very helpful to just be able to eyeball these things and say, well, yeah, what's a reasonable answer here? And so let me just change this slightly. This is going to be approximately 29 times 100. It's going to be a little less than 29 times 100. Which is 2,900. Now, coming over here and taking a look at the answer choices, so we said it's going to be a little bit less than 2,900. So it's not going to be D, it's not going to be E. It's very unlikely to be all the way down at B at 1,950. As I say, I want a little bit less than 2,900. To lose almost 1,000 by taking away a 29, that's quite a big one here. And yet, if you'd put this into your calculator, you'd have seen 2871 is going to be the answer to this question. And so C should be our answer. So as I said, right, the arithmetic, because you've got the calculator, the actual arithmetic shouldn't be that tough, but it's about interpreting the question. Make sure you don't slip up. Make sure you don't get these inequality signs the wrong way around or misinterpret them as a less than or equal to, which they're not. They're very much strictly a less than. And then at the end, it's good to be able to eyeball the answer. You might slip up and press the wrong button in the calculator, and we want to avoid that leading to a mistake. And so just being able to say, well, the answer should be roughly this can get very helpful. All right, we're going to keep this going. I will get the next question up on the screen for you now. We'll give you a couple of minutes to take a look at this one, and I'll see you back here soon. Okay, now's your chance to pause it if you want some more time to have a think about this one. But for now, let's take that question away so that we can look at it together. All right, so you could consider this question like the algebra version of the previous question, where the challenge here is to really figure out what you're being asked to do. And once we've got that, the actual work shouldn't be that tough. So what I'm looking for here is what is the relationship between R and S. And when you see a setup like that, what you're really looking to do, eventually, I'm going to be looking to do R is equal to something with an S in it. Don't know what that's going to be, but there's going to be R equals some stuff going on with an S in there eventually. And now what I have to begin with is the equation I was given to be at the start. So 4R minus 3S over R plus 3S is equal to 5 over 2. And now that I know that what I'm looking for is R is equal to something, then I can just start working with this equation to get down to make R the subject here. And hopefully at this point, the question is beginning to make a bit more sense, and we're going to be able to work through the algebra here. So to begin with, what I would do is multiply both sides by R plus 3S and multiply both sides by 2 in order to get rid of the fraction, because I don't like fractions in equations. I want them all on one line. That makes things much nicer. So I'd end up with 2 times 4R minus 3S. That's equal to 5 times R plus 3S. Expanding both sets of brackets is going to give me 8R minus 6X is equal to 5R plus 15S. Now I'm going to take all the R terms over to the left-hand side, push all the S terms over to the right-hand side. So 8R minus 5R is equal to 15S plus 6S, which is going to leave me 3R is equal to 21S, and dividing both sides by 3, R is going to equal 7S. And so now you can see I've got the equation, R is equal to 7S. I've got the relationship that I was looking for. R is equal to something with an S in it. Well, R is equal to 7S. And so R is equal to 7 times S. Now that I have that relationship algebraically, all I need to do is come over to the answer choices and say which one of these answer choices matches what I was given. Now, I just want to drop back into the question for 1 second to pick up on this word here. This must be true, because it is possible that even though R is 7 times S, that R is 3 more than S. You could probably jump around with the numbers and make that work. But it doesn't have to be true. This question, which of the following, must be true. And so the only one of these answer choices that must be true is E. R is 7, I've written that question slightly wrong. R is 7 times S, which is exactly what we were told algebraically in the relationship. So even though you could possibly make an argument that you could find a number for R and S that would make A work, or maybe make B work. I haven't actually tested that out, but I'm guessing that you could probably go about doing that. It doesn't have to be true. It doesn't always work. It doesn't work in every case. And so it wouldn't answer that question, which of the following must be true. The only answer choice that does that is going to be E. All right, so we're getting to this idea of trying to figure out what the question is actually asking you to do. And now one of the challenges in doing that is not to get intimidated when the algebra looks very nasty, and that's what we're going to get into with this next question. All right, so this question, I'll give you the warning here. It looks much worse than it is. We'll give you a couple of minutes to take a look at this one, and I'll see you back here soon. Okay, I hope that's been enough time to take a look at this one, but now's your chance to pause the video if you want some more time for it. All right, I said before we put this question up on the screen, I said that one of the challenges is not to get intimidated by the algebra because this looks fairly nasty. But as we're going to see in a second, it does collapse down very quickly into something much nicer. So what I can say about this is when you're dealing with a fraction, that the whole of the left-hand side must equal 0 to make it deal with the right-hand side. And when you've got a fraction that equals 0, what we can say is that the top line must equal 0. Because it doesn't really matter what's on the bottom. If the top of the fraction is 0, the whole thing is going to be 0, because 0 divided by anything is still going to be 0. So I can ignore the bottom line of that fraction and just say that this whole thing collapses down to x minus 1, x minus 2 is equal to 0. And now we've got something that looks much nicer already. Right now, we're halfway through the solution of a quadratic, and I just need to take it on a couple more steps. Like we said back in question 1, this is two things multiplied together to give me 0. So if I take that first bracket and say, well, that x minus 1 equals 0, that would give me x equals 1. And x minus 2 is equal to 0 for the second bracket. That would give me x equals 2. And I've got my two solutions, my two roots of this quadratic equation, either x equals 1 or x equals 2. Now, the final step with this problem is not to slip up here. Because one of the things dealing with a quantitative comparison question is people might say, I have two answers. And so because I have two answers, I can't tell what x is. So because I can't tell what x is, that means I'm not going to be able to tell which is bigger, so the answer would be D. But the thing to look at here is both of these solutions are bigger than 0. So while I can't tell from the information we've been given, I can't tell whether x is 1 or x is 2, both cases, those values that x could be, both of them are bigger than 0. So it doesn't matter which one of 1 or 2 it is. Quantity A is going to be bigger than quantity B. And so the answer to this question is going to be A. All right, so I'm going to keep that theme of trying not to get intimidated by the problem going as we throw the next question up on the screen. Now, this has a lot of text in it. Now, when a question like this has a lot of text in it, people are really tempted to try and read fast. Please don't do that. Please don't get sucked into that way of doing things. Take your time, read it really carefully. We'll take a look at the question in a couple of minutes' time. Okay, if you need some more time to think about this one, or even if you need some more time to read this one, now's your chance to pause the video. We'll still be here when you're done working on it. All right, so like I said before, I threw this question up, a lot of text going on this one. And now what we're aiming to do with these long questions is not to rush the reading. As you'll see in a second, the actual amount of work you need to do in a problem like this is probably not that big. The difficulty is going to be in dealing with the text, picking out the bits that you need, and understanding exactly what you're looking for. when you've got a question like this, the actual amount of algebra is probably going to be quite low. All right, so what we're actually asked for right at the end of this question is how many days? How many days will the company's fuel supply last? So right at the end, I'm going to have an answer that says some number of days. Don't know what that is yet, but that's what we've got to go and figure out. So long word-based questions, one of the things you can do is say very precisely, what is it I'm looking for? Then we've got, what information are we given? So I know that I have enough fuel to keep 20 trucks going for 36 days. So 20 trucks for 36 days. I have, or the haulage company has, 720 truck days of fuel, which I know is a very strange unit. But what that means is, well, I could keep 20 trucks running for 36 days, or I could keep one truck running for 720 days, or I could keep 720 trucks running for 1 day. I have enough fuel for 720 truck days. All right, now what happens in the next part of the question? 4 of the trucks are going to fail a maintenance test and they're going to be permanently banned for driving. So what I can say is I no longer have 20 trucks. I have 16 trucks. I don't know how many days that's going to last me, but I know the amount of fuel hasn't changed. I've still got 720 truck days of fuel. So rearranging this, if I divide both sides by 16, by the 16 trucks, I'm going to get the sum number of days that I want to. So really the final step of this question that we're going to be doing is going to be 720 divided by 16. Now again, GRE, very nice. We can just throw that in the calculator and you're going to get an answer of 45 days there, which means that the answer to this question is going to be B. All right, so as I said right at the start of this problem, huge great wall of text, but when that happens, it's likely, not always, but likely, that the amount of work you've actually got to do isn't that big. Now, I've written everything out here so that we can see what's going, but really, we've got three lines here. So when you get a huge word-based problem like this, take your time. Please don't rush the reading. That's maybe the worst thing you can do. Understand exactly what's going on. Work the problems through nice and smoothly. It's likely it's not going to take you any longer than some of the shorter, less word-based problems. All right, we've got 2 questions left for you today. As I said, the difficulty level is beginning to ramp up. So if you're aiming for something over a 160, maybe not up to a 165, but yeah, in that 160, 161, 162, hopefully those are going to begin to challenge you a little bit. If you're only aiming for something in the low 150s, maybe up to a 155, it's lovely if you're going to be able to get these 2, but it's not necessary. So don't worry if these are beginning to be very challenging. All right, I'll get this next question up on the screen and I'll see you back here in a couple of minutes. Okay, pause here if you want some more time with this one. But I'm going to pull the question away just there. All right, so we've got a quadratic inequality here. If I was to expand those sets of brackets, we'd get a quadratic equation. So quadratic inequalities. There's a little bit more to these questions. So what I'm actually going to do to begin with is I'm going to ignore the inequality, and I'm going to take a look at what would happen if this was an equation that equaled 0. And we're almost there. We've done this a couple of times already today. So I would get the roots x equals 2 and x equals -3. Right, and that gives me what we might call the boundaries. That gives me places to look. So if I set up a bit of a table here, x equals -3 can go there, x equals 2 can go there. I'm not going to look at what happens on those points because I know that would equal 0. But I can look at what happens when x is less than -3, or in this point between when x is between -3 and 2, or at this point where x is greater than 2. And I can look at the value of this inequality at some of these points. So I'm going to start over here when x is greater than 2, and I'm going to go big. Let's say what happens when x is 100, because the number itself doesn't matter. I'm just looking for whether the outcome's positive or negative. So if x was 100, then what I'd have here is something like if x was 100, I'd be dealing with 98 from x minus 2 times 103. Now, I'm not going to go figure that out. I'm not even going to put it in the calculator. It doesn't matter. The point is 98 times 103, that's going to be positive. It's going to be greater than 0. And so what I can say is that when x is bigger than 2, this inequality is going to be positive. Now, you can go and check that with some other numbers. Try x is 10, x is 5, x is 20, whatever you like. As long as x is bigger than 2, that inequality is going to be bigger than 0. And I'm not looking for this section because I'm looking for when the inequality is less than 0. All right, now we could try this middle bit. So picking a number between -3 and 2. Let's just see what happens when x is 0. X minus 2, well, if x is 0, that would give me -2. X plus 3, if x is 0, that would give me 3. This is a nice easy one. I could tell you that's -6. The number itself doesn't matter. The important thing is that's negative. And that's the bit that I'm wanting. All right, one more of these. Again, you could go and check them. I'm going to leave that to you. If I chose a number where x is less than -3, what I'm going to find is that overall inequality is going to be positive there. Right, now, just a bit of a caveat in here. What I want to avoid in this question, I want to avoid testing numbers. Now, you might say, well, you've tested some numbers there. And that's what I want to get at, this difference. There's a difference between choosing numbers to make a case and testing numbers by saying, well, what happens if x is 5, 6, 7, -2, a half, 0, 1, 3. That second case where you're just throwing numbers at the question, seeing what sticks, that's where you're going to end up burning through time. In those cases, what I'd say is you're not sure where this question's going, stick the flag on the question, move on, come back to it at the end of the section when you've got the time and deal with it then. What I've done here is I've chosen some numbers in these ranges in order to make the case. What I'm looking for by choosing x as 100 is, well, is the inequality positive? And yes, it is. And I have to say, you could choose any number greater than 2 and you get a positive number there. You could choose any number between -3 and 2 and we get negative. And you could choose any number less than -3 and get a positive sign there. Now, in this question, what I'm looking for is what numbers give me this inequality being less than 0, and that's in this range here. So between -3 and 2, the inequality is going to be negative, which is less than 0, which is what I'm after. So moving over to the answer choices, I'm looking to find all, so not necessarily just one answer choice, not one answer, all the inequalities that would make this overall inequality equal 0. And I know that's going to be between -3 and 2. So looking over here, answer choice B will give me between -3 and 0, and C will be between 0 and 2. Those are both the range that I'm looking for. So my answers to this question are going to be B and C. All right, so that method, that sort of build the table method of looking at quadratic inequalities is the way that I would go about trying to be as efficient as possible, making sure you know exactly where the inequality is going to be positive or negative, or positive again. And that'll hopefully lead you to an answer relatively quickly and smoothly. All right, we've got one more question for you today. So hopefully this will be a bit of a challenge. I'll give you a couple of minutes to have a think about this one, and I'll see you back here soon. All right, for the final time today, if you want some more time to have a think about this question, now's your chance to pause the video. We'll still be here working it through once you come back and join us. All right, so final question here. And like before, yeah, there's a bit of text going on here. There's a bit to read. And so when you've got that, I'm going to really focus down on what is it precisely that we're looking for. Now, the question is, which of the following must, we've got that word again, must. So it absolutely has to be, it doesn't matter whether you can find some way of making it the square of an integer, it has to be in every occasion. And which of the following must be the square of an integer? Now, if it's going to be the square of an integer, what I can say is I should be able to rearrange these options so that it's some sort of integer in a set of parentheses squared. What's inside the sets of parentheses must be an integer, and I'll square the whole thing, and that'll mean that I know it is the square of an integer. Right, I'm also told that if p is the square of a positive integer. So p is going to equal, I'll just say some letter k squared, and I know that k is greater than 0. And so we're going to use those various bits together. I'm going to take a look at these answer choices and see where we get to. So A here, 144 times P. Well, if I use that substitution, P equals K squared, I can say that's 144K squared. And 144, that's 12 squared. So 144P is the same as saying 12 squared K squared. And that would mean that I could rewrite the whole thing as 12 times K in a set of parentheses squared, which is exactly the setup that we were looking for, an integer squared. And so A, yes, I would click A. A is going to be one of our answers. All right, taking a look at B here. First step, I'm just going to rearrange this. I'm not going to do anything. I'm not changing anything. I'm just putting it in a different order. If I say that's P plus 12 root P plus 36, then if I use this substitution P equals K squared, I get K squared plus 12K plus 36. Now, this is one of a small number of sort of what we might call standard quadratic results. I'll show you what the three of them are in just a second. But what I can do with this, if I can recognize this is one of the standard quadratics, I can put that straight into K plus 6 and square it. Now, as before, we said that K, we know K is a positive integer, so we know K is an integer. If I add 6 to an integer, I definitely get an integer, and then I'm going to square it. So this, K plus 6, that's an integer, squared it, that's the format we were looking for, and so B is going to be one of our answers too. All right, I said that there were 3 of these standard quadratic forms, and I'm going to get them up here. There are a very small number of things that would be helpful to memorize in order to get through the GRE Quant section, and this is one, or these are going to be some of them. That what we could say, this format, I might say that was in the format a squared plus 2ab plus b squared, where in this case a was k and b was 6. That you might rewrite as a plus b all squared. So that's one of them. The second one, very similar, a squared minus 2ab plus b squared. That's a minus b squared. And the final one, a squared minus b squared. You might see that written as a minus b, a plus b. And that bottom one, also known as the difference of squares. So those 3, it's not vital that you know them, but as you can see with how we dealt with that, I didn't have to try and factor it. I didn't have to put it into 2 parentheses and then realize they were same. Once I realized that they were in this format, I can just jump straight to that standard format, and it just saves me a bit of time. All right, so A and B, we know that those expressions, those must be the square of some integer. Let's check out C next. So just like with B, I'm not going to change anything. I'm just going to rearrange it. So P squared plus 9P plus 9. And so I've got myself a quadratic again. Now the challenge here is that I can't get this into a set of parentheses. I can't get it nice and neatly into 1 or even 2 of them. I can't find 2 numbers that will multiply together to make 9 and add together to make 9. It's just not going to be possible. I could do other things with this quadratic, and we're going way outside the GRE syllabus here, but things like using the quadratic formula or completing the square, doing things like that. In that case, yeah, I'm going to be able to do something with the quadratic, but it's not going to get me what I'm looking for. I'm not going to be able to put this inside one set of brackets with a square on the outside. So C, not going to be one of our answers here. All right, final one, dealing with D here. It's the reverse of one of our standard quadratics from earlier. So I could, if I wanted to, go and expand those brackets, and I'm going to get P minus 25. And since I know that P is K squared, I could go and rewrite it as K squared minus 25. I'm wasting a bit of time here, but doing it as an illustration that it's sort of, can I get this into the format I'm looking for? So one of the things to deal with these questions is always to remember, what is it you're aiming for? I'm aiming for this format, the integer in the set of parentheses with a squared on the outside. It doesn't really matter how I rewrite this. I'm not going to be able to get it into that format. And so D is not going to be one of our answers here. So this question, I'd click A, I click B. Those two are going to be the squares of integer. C and D are not. And so our answers for this question is going to be A and B. All right, so that is hopefully a helpful introduction to some of the arithmetic and algebra you're going to need for the GRE. As we move through the video, I've tried to show you the different things that you should look out for in a question. Things like, yeah, don't rush when it's a really long word-based question. Also, please don't get intimidated just because the algebra looks horrible at the start. It might collapse down very nicely as you're working through. All right, so that's all I've got for you today. Hopefully this has been helpful, and we look forward to seeing you again at one of our other GRE Quant videos very soon. Thank you very much, everybody. Have a great day.